All right. I think I'm good to go. One last check. Boom. All right, welcome everyone. My name's Aaron Evans. I am a QA strategy consultant, and my talk is called Becoming the Bottleneck. The original subtitle was Embracing the Challenge of Something Something. Changed it to A Tale of Woe about the challenges of Agile testing. And I don't know about you guys, but I'm tired. This is my performance part. I need a drink. It's just root beer, sorry guys. All right, so I'm gonna need the clicker. Bottlenecks. What's a bottleneck? Well, this is a bottle. This is the neck. End of discussion.
Mic drop.
Yeah, see, but let's get a drink in. You hear that glug glug? What causes that? The vacuum letting the air in, the seal from there. The bottleneck causes the glug glug. So that's my illustrative example. Everyone, if you want, I got a cooler full of drinks. You can come on up and grab a bottle, take a drink. There's a variety, everything from ginger ale to root beer to black cherry or whatever. I just went to the store last night, grabbed a whole bunch. Went to Publix. They didn't have a cooler, so I had to go to Walmart to get the cooler. And then I asked the concierge to help me bring it down because they've been sitting on ice for a couple hours. They're like, yeah, we can help you. No, we don't have any luggage carts, but we got a dolly and bellhop will bring it down for you for $60.
For $60.
So I put it on the chair from my room and I wheeled it down, nearly tipped it over getting into the elevator. And yeah, come on up and get a drink if you want.
Creative way to get it there.
I put stickers on, if you notice, QA strategy. And I've got.
Time to rate and review the session.
Yeah. Sorry they're not better drinks, but I figured bringing in something a little stronger might get me in trouble.
First object lesson.
Yep. Anyway, the reason I thought of doing this was a long time ago, well, a few years ago, I got very sick. I was in the hospital, and I couldn't eat anything. I was actually hooked up to an IV delivering TPN, which is some kind of sludge that they pump into your system when you can't eat or hold anything in your system. So for days, I was just watching Food Network because nothing else was on and torturing myself. And I got to thinking, you know what I want to do when I eat is I want to get all these, custom label root beers or whatever, everything from Walmart brand to A&W, IBC, whatever, do a taste test and figure out what the best root beer is. And so I got a bunch of bottles, and I thought, that'd make a great opener for a talk. So here we are 5 years later or something. All right.
Were we in your vision, or was that optional?
I was dreaming of you in my fever, yeah.
That's why I'm up front.
All right, so let's get started. Have I killed like half my time already? All right, so what is a bottleneck? That's kind of how I started off, right? Well, let's make this like a Q&A, right? Kind of like I'm going to teach you using the Socratic method. Anyone other than my definition have something they want to define it with?
Constricts flow.
It constricts flow. Is that a good thing or a bad thing? It depends.
I wanted to say that to every one of you.
You're brilliant. You'll make a great consultant one day.
Well, thank you.
What's that?
So thank you.
All right.
If you're an electrical engineer, it's resistance.
Resistance, yeah. A resistor is a one way of describing a screen. Now, what problems do bottlenecks cause? Anyone?
Backup, slow down,
Backup, yeah, slow down.
confusion.
Could cause confusion, or confusion could be the source of a bottleneck. got a slide that mentions that later. There's some other things I've got in mind as well, but those are all good answers. Anyone else? Maybe we should get a secretary to write on the board. No. You'll never be able to read my handwriting, and it'll take all my time to spell it out incorrectly. All right. Anyone ever experienced a bottleneck at work? I heard resistance in electrical systems. Got a quick example, anyone?
Formal phase gate reviews can be a bottleneck.
Say again?
Phase gate reviews can be a bottleneck to flow.
Okay. I don't know what that is.
Stopping the work to talk about the work and what you did before you moved on.
All right.
Yeah.
All right. Why do bottlenecks happen? We talked about constriction, right? The vacuum seal as you remove liquid, but you don't have air to replace it. That's the glug, glug, glug. All right. And how can you avoid bottlenecks? Is it always possible? Not always. Sometimes. We'll talk about how we can do that later. All right, roadblocks. First thing I want to establish is roadblocks are like bottlenecks, but what's the difference between a roadblock and a bottleneck? Yeah, a roadblock stops the flow, road closed. Bottleneck, you can imagine what a bottleneck in traffic is, and I've got a slide for that later. Any examples of a roadblock? And I'm thinking in general terms of software delivery. That's kind of,
You have to go through security, right?
yeah, going through security. Like security reviews or like security code?
Security in general. No, you're
Security,
talking
yeah,
about-
security is a pain in the butt.
If you're a security guy, people don't like security.
Yeah, the keynote this morning, Nathan, he's a security guy. He's a bottleneck. Critical defects, yeah. A roadblock that you got to stop, in theory, or you just got to ship. Roadblocks can cause bottlenecks, like even after you remove the roadblock, and you probably experienced that. And bottlenecks can become roadblocks, right? A traffic jam, which is how I want to illustrate this. This is a pretty big traffic jam. I live in a tiny town in Montana, and we don't get things like that, but every time I go to the big city to go to a Walmart or something, I'm surprised by traffic. So, some examples of problems you run into traffic. A constriction, a choke point, or a closed lane, right? Just talking about traffic on the road in general to imagine bottlenecks. Surge in demand, Black Friday, a rush hour, end of sprint, when you've got to get all your code checked in and tested and working and deployed. Not enough capacity, not enough people to do testing, not enough servers to run the app, things like that. Accidents, disasters, critical defects, things like that. Competing goals. Two people want to get through, you know, the old stand-up comedy thing, or not stand-up, sketch comedy, where two people try to walk through the door, but there's not enough room, you get stuck, or you've got to wait. Merge conflicts. That's your classic onboarding ramp. Nobody knows how to zipper in. Same thing happens with code. That's why we call them merge conflicts. How do we deal with roadblocks and bottlenecks? Rules and processes are one way, right? We can make prescriptive rules. I might have this backwards. Do this, right? Always run your tests before committing your code. Proscriptive rules. Do not check in production passwords into your GitHub repository. Things like that. Rules, benefits, and I always get frustrated when I do this click for animation. I've got this thing, forgot. So there's benefits and drawbacks to rules, right? On the one hand, you know, a stoplight keeps cars from crashing. On the other hand, it slows you down in theory. But the idea is that it allows you to go through at a restricted rate in order to prevent bottlenecks and roadblocks from becoming an issue, right? A bottleneck is if everyone's trying to go through an intersection, you got to take turns. Better to have some way to control the flow which leads to roadblocks where someone's not waiting their turn. Some rules should probably just be considered guidelines. And you've probably all been at the four-way stop or the stoplight. I don't know, city folks. But in the country, we treat those as guidelines. If no one's around, go for it. One problem with rules is they can build up, right? One rule that was valuable at one point can become less valuable, especially, if traffic moves to a different area and this road no longer needs a stop sign or stoplight. And that can lead to things like bureaucracy, where you've got a bunch of rules and processes that may or may not have had a valid reason for existing at first. But they build up as cruft, and we need to be able to prune those rules or reevaluate them. That's one thing we can do to prevent those sorts of things becoming constraints. Now, rules and guidelines are one type of constraint, right? It constricts flow, hopefully for the good. But you've probably all heard of something like the iron triangle, right? Or the project constraints. Fast, cheap, good. Pick two, or whatever, right? So we've got these three competing goals: speed, quality, and cost. And there's an iron triangle, or it's an immovable, right? You can't just grow one without shrinking the other. If I want to move faster, I'm going to have to pay more to get more people working on the project. Although then you've got what sometimes called the mythical man month, or the mythical woman 9 months. You can't make a baby any faster with 9 women, if you haven't heard that one. Or you might have to sacrifice quality. But we've got to find a way to break this, right? It's a movable, fixed. We've got fixed amount of resources. What do we have to do if we have to release faster, or we have to reduce costs, and we can't sacrifice quality? Anyone have a solution?
Restrict scope.
Bingo! Everybody take a drink for that good answer. You can reduce scope. That's one of the primary agile strategies or philosophies. Shorter iterations. You can still deliver on time. You can't deliver as much, but it prevents you from getting a long delivery path where bottlenecks and roadblocks can build up. And as a teaser for a future slide, where you can develop waste. If you have people waiting in line to commit features, and then the business need changes, and they've done all this work, well, we'll get to that later. All right, testing is a bottleneck. I'm a tester. I love testing. If you saw my preview, it's because I like to break things. I punched a keyboard and the keys went flying everywhere. And a week later, my wife came out to my office, and she's like, why are there keyboard parts all over the floor? So I had to explain it to her. Anyway, so testing is a bottleneck. Would anyone disagree with that statement?
Testing is software development.
Yeah? Well, sometimes. Sometimes it's hard work.
Writing code is the bottleneck. Write it faster.
Yeah, sure. But as a tester, I contend it's a bottleneck. But we might think of it as a bottleneck like a stop sign or a gateway, testing as a gateway. That maybe we want to slow down. Maybe we want to constrict the flow for a good thing. Oh, is QA a bottleneck? I think I used to have a yes in parentheses right there. Does it have to be? Maybe not. In some cases, who was the one who said it depends? Yeah, take another drink for that good answer. All right, how can you tell when a bottleneck is necessary and good, or at least must be endured, or when it's not? I guess that's later. This is how can we tell if it is a bottleneck? Well, it's testing. You hear something like this. Testing is slow. We can do it at the end. Anything that's put off till the end is probably a bottleneck, or it's lower priority. If you do something last, it's probably lower priority, or, right, you can't test until you have something to test, in theory. I like test-driven development, or as I like to call it, defect-driven design. If there's a lack of communication between testing, testers, QA, whatever you call it, and somebody get this man a drink. If there's a lack of communication, that might be a sign of a bottleneck. There might be a reason for that lack of communication, or lack of communication, or the lack of ability to communicate, commute traffic. Communication itself can be a bottleneck. I work with a distributed team. We've got folks all over. Sometimes just time zones make bottlenecks, right? You've got to wait 24 hours for the team in India or Ukraine or wherever they're at to be able to respond to something. If you're in a silo, if testing, you throw it over the wall. If you're doing Agile, that doesn't make sense. But you hear that phrase a lot, right? But you do that by throwing it over the wall more often. Short iterations are better than long iterations because at least there's less waste if you make a mistake. But a cascade is still a waterfall. If testing is perceived as a cost center by management or whoever else, it may be because it's a bottleneck and you feel like it's slowing things down unnecessarily. What gets cut when you're out of time or out of money?
Testing.
Quality, yeah, testing. Now, testing, to be clear, is not the source of quality. It's not some magic quality dust you sprinkle on. Although I've had managers say that, like, go do QA, you're the expert. Okay, what do I QA? Do QA, do quality, do Agile, whatever. And then last thing is assign something maybe a bottleneck is because you underestimate the complexity of it. A big example of that is in testing, right? A small development change can have a big testing impact, right? A simple example, you've got a HTML template on a website, and it's on every page. It's the menu or the sign-in form or something like that. Developer makes a change in one file. It's one line change. Boom, it affects everything all over the site. Say it's the sign-in form. So there's bottlenecks, or testing is a bottleneck. We've established that. There are bottlenecks within testing as well. Anyone have some examples? I'm just going to click through all these. These are examples that I have. I need to figure out the time. 15 minutes. I'm not doing too bad. Right, creating test cases, scenarios, understanding requirements, executing tests, whether it's manual or automated, writing automation, waiting for the automated tests. Anyone ever complained about that before? Yes. When are the tests going to run? We'll talk about things we can do for that. Quickest answer is make the tests complete faster. Two things you can do. Parallelization, run more tests at once. That's a lot harder in practice than it sounds, usually. The other one is test less. Okay, anyone here have testing experience? All right. Anyone here know of a test that's useless? Yeah, all right. Now, here's one of my catchphrases is, what is the, and then it's kind of a trick question, what is the optimal pass rate for a test? Like percentage? 100%? 80%? Yeah, let's be a little more realistic, right? Any other numbers? 62, did someone say? Or 69?
42. 42 is the real answer.
42, that's pretty good. I submit it is exactly 50% optimally. A test fails, and then it passes. It doesn't tell you anything new until it fails again. that means you have a perfect test, right? Because if it passes and you already knew it was passing, it's waste. It's a warm, fuzzy blanket of waste, and it's probably a good idea to know that it's still passing. But right, the optimal pass rate with zero waste is it fails every time it needs to fail. It passes only when you know it's not failing. Let's see. How many times have you heard or asked or said, when will the automation or the automated tests be ready? I've heard this one. When the automation's done. Done. Is the development going to be done? Is operations going to be done? There is a lot of setup often, especially in new projects or on new teams. You've got to learn tools, you've got to build frameworks, you've got to establish processes. Those are bottlenecks. And I've seen that a lot, especially you start a project. There may be a few months before you get kicking with a good test framework, strategy, run, whatever it is. This is probably the most common one. Troubleshooting false positives. A test is failing. The developer says, it works for me. And wonder of wonders, the developer is right. It does work. The test is wrong. And as a tester, I've spent a lot of time troubleshooting false positives. It's time for a story. I did say this is going to be a tale of woe. I think I missed my last example I want to tell. But I worked at a company a while back that this was way back when Agile processes were new. They didn't even know you could capitalize the A in Agile. It was like extreme programming and stuff like that, and pairing, and a real board with sticky notes on it that we moved around. It was a great job, great people. I learned a lot about Agile processes. But every morning, first thing I'd do to come in, before the stand-up meeting, I'd look at the build, look at the run, the test run that ran in CI overnight, and I would hustle to find out if any of those test failures were false positives or if they were real issues. Manual review, probably better than the alternative, which was manually testing, but I had to check to make sure those false positives, so I could go to that stand-up meeting and say, yeah, the build had 9 failures, 7 of them were false positives, 1 of them's a known issue, this other one we really need to talk about. And then lastly, maintaining tests, whether it's manual test scripts and requirements or test automation as the product changes. Comment?
I noticed you didn't have setting up the test environment that you're going to test.
Do I have that on the next one?
Oh.
All right. Setting up test environments. Oh, drink for the good comment.
Good segue there.
Yep, okay. So there are bottlenecks within testing. There are bottlenecks to testing. Definitely setting up the environment, the code being deployed, doing test data setup. I need a user who's been canceled and renewed, but their credit card is expired. Weird scenarios like that. We need to test when the database disk is full or something like that. Those are also things that we need to do. Lack of or unclear requirements can be about, we need to understand, we need to communicate, we need to play telephone with the representative of the business who represents the customer, right? Talk to someone about what the actual requirement is. Just knowing domain knowledge, right? Whether it's accounting or aerospace, your testers may not know everything, but the good testers, especially after they've stuck around, become those domain knowledge experts. I know a tester who the product owner probably has an insurance policy out on her because she knows the system better than anyone at the company. And then, I said earlier, but just like environments, you can't test something in theory until it's ready to be, right? Until it exists, until it's deployed. You can't deploy until it's written and it compiles. And then we mentioned right at the start, blocking defects can be roadblocks, but they can also be bottlenecks. Writing a defect, right? Logging the defect, taking a screenshot, getting the log files, describing the steps, reproducing it because you were just fooling around when you found the bug and you don't know how to say how you caused it. That slows you down too. And then lastly, priorities are not understood. Again, like writing tests that don't matter, or writing tests that matter less, or not understanding that testing or keeping the existing system running is more important than developing the new features, or vice versa, right? It could be true. Other bottlenecks. So things outside of testing. Processes and people, bureaucracy, everyone's favorite boogeyman, technology, learning technology, the flakiness of technology, scheduling, getting people together, meetings, things like that. And we've got to wait for the customer to approve or something like that. We don't have the time, the budget, the resources to do that. All right, let's talk about dealing with bottlenecks. So another story time. Once upon a time, in my first real IT tech job, I worked at I used to be able to say a company in Redmond, Washington, and you'd know what that company was. But it was Microsoft. Right, anyone would know if you worked in tech in Washington State, it was Microsoft. But I didn't know what I was doing. I actually had never completed my degree. I'd started a computer science degree, went off into art classes and snowboarding and pottery and audio production, anything but learning something useful or learning something for my major, I should say. Anyway, but I had a friend and I got a job at Microsoft. This was 24 years ago, in the year 2000. Any Conan O'Brien fans remember? In the year 2000. All right. For you kids, it was a funny bit. Anyway, I think it was Andy that did that, not Conan, right? Thanks. Anyway, I distract myself too easily. So I got the job because of my friend's reference and because when I went up to Seattle, I worked in Southern Oregon at the time. I was remodeling a house. And one team I interviewed, and I sucked at foosball. Didn't get that one. I also couldn't tell the difference between an IDE and a SCSI connector. It's probably a hardware job, and I didn't want that. Another team I did get hired for because I answered one of those brain teaser questions. And I answered it in a novel way, and being who I am, that novel way was extremely inefficient in my hallmark. Anyone ever heard the one about, I think it's the 3 light bulbs, how do you tell 3 light bulbs and 2 switches?
Yes.
All right, so the idea is, how can you tell which switch works, right? The light switches are outside the room, the light bulbs are inside the room. You've got 2 switches, how do you figure it out? Well, I don't know the actual answer. Here's my answer. You turn one switch on, and I was trying all sorts of things. Can I use a multimeter or whatever? I don't know. And I said, well, how long do I have to figure this out? The interviewer's like, as long as you want? Okay. I wait several months, maybe a year. All right? And then I turn the other light switch on, go in the room, and the light bulb that's burnt out, of course, is the first one. The one that's on is the second switch, and the third one, who knows why it's still on or off. Anyway, so that's how I got a job at Microsoft, totally unqualified. But, but what I was doing is I was babysitting the build. In the year 2000, there was no such thing as continuous integration. I think the phrase had been invented, but nobody used it. We had a manual continuous integration process. We had automated tests. Unlike most teams at Microsoft, we had source control. This was a while ago. Microsoft has gotten better since then, mostly because of me. Just kidding. But there was this big old power transformer in a bit lab, probably twice the size of this room. And next to that was this mainframe system, which had the source control. And then there were racks of shelves. We're talking like ghetto Kmart shelves, you know, those little metal arm racks and stuff, with all sorts of computers on it, hundreds of computers, and it would run a battery of tests across all these different computers. And part of my job was to go around the room, you know, every half hour or hour, walk the aisles and look for the loose peanut desks, look for crashed computers. And it being Windows, there were a lot. It being, excuse me, it being mostly Windows 95 and 98 and the initial release of Windows 2000, which was really buggy, but it turned out to be a good move. NT. Did that a lot. But also, I'd kick off a build. It would deploy to some 300 different machines. I would look through the logs and I'd see, you know, failures and stuff. And I would try to figure out if it was a known issue or something new. Now, this got to be a problem because there were known issues and a lot of them would look similar. The stack traces might even look the same or similar. But when you've got a 40-line stack trace and to figure out, you know, foo bar baz impl line 263 invalid number exception looks very similar to foo baz bar line 257 invalid number exception. I can't even remember myself. Fake example, but the idea is when you have a bunch of issues, number one, you've got to check if it's a known issue. That's a bottleneck. Definitely slowed me down. It took longer sometimes to see if the issues that came up were real issues or known issues or false issues, or, right, than the actual test run. But the real problem was because there were known issues, because they were difficult to tell if they were unique, it crept up. We got up to 75 plus known issues, and at that point, the build was totally unreliable. We had people come in, and a lot of the issues were just performance issues, right? There were performance tests. This should render in, you know, 3 seconds or less or something like that. And there was one guy, Alex, who's from Romania, great guy, total computer hacker genius, right? He would come in, and at the terminal on the build server where I'm sitting, I mean, I had a KVM switch to go back and forth between different machines here. He would put the patch in right there, run it again. But what he was doing was he was bypassing that process, hacking in the code, and he was a whiz at fixing performance problems. And no one else could do it. So Alex was a bottleneck because he was an expert and he was the only one who could fix these problems. But also because he was bypassing the workflow of making sure code gets checked in and reviewed, and it was creating other issues. So that was a problem, an example. But that was a great learning opportunity, and I didn't even know it at the time because I learned what a continuous delivery process is. I learned what happens when you make exceptions and bypass it. And probably the most important and obvious lesson is I learned what happened when you allow known issues to creep in. It just gets to be more, and then people start distrusting the system and getting around it. I guess I've got a whole list of things here. Number one, you can put up with bottlenecks, and I was going to ask questions, but I think we're kind of going through the time here. Yeah, I'm over half over. Who has bottlenecks in their work that you just have to put up with, that are not bureaucracy? What was the example?
The system test environment and legacy mainframe.
All right. Why do you have to put up with it? Is it outside of your control, or is it just its nature?
It's outside of my control.
All right.
And its nature.
Okay, yeah. So, right, sometimes there's problems. If you were allowed to fix it, you could fix it, right? Or if you were allowed and you knew how to fix it, you would. Right? Sometimes that's resources. I think I had something on the previous slide about people or whatever, right? Sometimes the person, Alex, who could fix it is just not available. What about, how do you get through bottlenecks other than just waiting? You know, in traffic, you got, well, teach people to merge properly, right? Teach people to merge their source code. Please pull and fix any merge conflicts before checking into main. Getting around bottlenecks, again, that's another Alex example. You can try and get around your bottlenecks, but that doesn't solve the problem. You can avoid bottlenecks. Well, you can eliminate rules, or you can maybe implement a good rule, create that stoplight, which avoids bottlenecks from forming, although it may appear to have a performance or a bureaucracy cost up front. I'm going to need another drink because my throat is sore. So go ahead and talk amongst yourselves. Let's see. Cream soda? Cream soda. Did you guys steal all the ginger ales? Okay, Sicilian lemonade. This one's here. Oh no, this one's not a twist off.
Do you want this one?
No.
Bottleneck.
All right, the little ones, you're gonna need your own bottle. Here's a ginger ale. All right. Cream soda it is. What I missed. All right, avoiding bottlenecks. Maybe you can avoid removing bottlenecks. Probably an ideal solution, right? If you can remove a bottleneck, widen that bottle. Oh, I've got another object lesson. Look. All right. Now, if I was a true frat boy, I'd be able to guzzle this in one gulp, right? No bottleneck here. Removing bottlenecks is a good thing if you can do it. But you can't always, right? It's out of control. You don't have permission. You don't know how. It's the nature of the beast. Maybe it's a good thing too. Preventing bottlenecks is actually better than removing them. An ounce of prevention is worth a pound of removing bottlenecks, something like that. But you can anticipate them. Maybe. We'll talk about how you can identify or plan to anticipate them. Causes of bottlenecks. We've already talked about some of these, so we'll just click through this. Insufficient capacity, not enough people, not enough machines, not enough money, not enough wire. You've got 14 gauge copper, you need 10 gauge to push, 40 amps or something. Any electrical engineers know the answer to that? Handoffs. I switched this slide like an hour before this because I wanted to use that, and I had another ship in the bottle, which is kind of a cool symbol, right? You get it? A bottleneck with a ship, a bottleneck to shipping. All right. But anyway, this is not you probably noticed in the other pictures. I had a lot of fun and wasted a lot of time doing those. A handoff, right? Once upon a time, I worked at a company, and we were pretty agile working together, but developers had written this test framework. And when I came in, it needed fixed. There were thousands of tests. It took hours to run. And you know what the tests were? It was this JSON template of test data, and not really, it was a very data-driven app, right? It was business intelligence, so a lot of algorithmically processing of data. So in most cases, if the number 42 came up, then it was working as expected, right? It wasn't always 42. Sometimes it was 9,007.3. And so we had all the tests were test data, and they ran through this monolithic test engine, interpreted the JSON, and spat out the table of correct answers. It was like airline traffic and stuff. But handing off to testers, well, the tester had no domain knowledge. He didn't understand the business analytics. Actually, probably most of the developers developing the code didn't either. Some of the really top-notch guys definitely understood the airline market. But so handing off, there was information lost. Or sometimes it's just time, right? If you have an automated process that needs a manual review, acceptance testing, or we need to hit deploy, and then we need to hit run tests. And it's different people doing that, right? Your DevOps guy or your developer or whoever. I don't talk that much usually. All right, and it's a good thing I don't have something that'll slur my speech. Instead, I'll just spike my, I don't know, what sugar. Anyway, the story was, you know, the testers ran the tests, the engineers ran the deploy, and so, right, if I'm out to lunch and the developers need the test kicked off after deploy, you gotta wait an hour and a half if I'm having a good lunch. 2 hours if I don't bother checking my messages when I get back. So that can be a bottlenecks testing. Approvals, obviously, we talked about things like acceptance from business or whatever. Incomplete or unclear requirements, that's a common theme. It can be anywhere. Lack of collaboration in silos, those kind of go together. Inefficient or complex processes, bureaucracy, internal apps. Who develops internal apps here for systems? A couple of you guys? You are not UX engineers, are you? Just kidding.
Everybody's a designer.
I read a good article about that recently. Yeah, everyone should have design awareness, just like everyone should be interested in, right? If you depend on a user experience person to improve your user experience, it's not going to happen. Just like if you depend on QA to create quality, it's not going to happen. Similar thing. Competition for scarce resources, right? We talked about that already. Especially, you know, you've got an individual or a team or budget can cause restrictions. Excuse me again. Let's identify some bottlenecks. The first thing we need to do to be able to solve them is identify where the bottlenecks are, and then we can figure out what's causing that bottleneck. So maybe these slides should be in the reverse order. First thing we want to do is we want to do what's it called? Value mapping in DevOps. You want to visualize how things are going through the system. You want to measure each stage of work. Which ones are slow, which ones are longer? You can only go as fast as your slowest system unless you can get around it. And then track the work in progress. Now, any Scrum Masters, Agile certified, anyone in here? All right, close your eyes and ears. This is a Kanban board, Kanban, whatever you want to call it. Where's the bottleneck? So this says backlog planning, development, testing, deployment. Testing, right? So testing has all these tasks to complete. Why? Because testers are lazy. And other things that we've talked about. So in this case, testing is the bottleneck. Now, we can also see the backlog's building up because, well, it's actually better than if everything was in development. Now, for you Scrum Masters and Agile coaches and all that, go gentle on me, but this is not used for planning. This is not a status check. The Kanban board, its purpose is to visualize bottlenecks. It's not to say, Aaron, when is task number 1, 2, 3, 4 going to be done? Why didn't you do it, you slow, lazy tester? I mean, go ahead and tell me that, but that's not what the Kanban board's for. Anyway, yeah.
Your Kanban board should have some aging or something like that. You don't know if a developer was a bottleneck and just dumped everything on the testers, right?
That's true. I don't remember if I talked about that already, about how I talked in terms of release, like Black Friday, right? That capacity, right? Developer capacity dumps them end of sprint, right? Oh, it's Friday morning, start testing. Better have it done by noon because we do not want to deploy after 5. All right, so let's look at this. So, right, we track our work in progress, and the reason of that is to identify the bottlenecks. We all know testing is the bottleneck anyway, so. And then we want to look for common signs or signals. Remember that? How can you tell if something's a bottleneck? Same sort of thing. Long feedback cycles, idle time. So we talk a lot about things getting backed up, right? Everything's backed up in testing, but what we don't always talk about is our SRE or DevOps or whatever we call them. Excuse me. They're sitting idle, waiting for those lazy testers to finish. That's waste, right? Come on, SRE's sitting there. Back in my day, they were playing things like World of Warcraft or whatever. You know, the type of games where you're just grinding, clicking on a button to level up or whatever. Without actually, anyway, I'm just saying DevOps are lazy bastards too. But they get away with it because testers are lazy and they are the real bottleneck. Anyway, single point of failure. My friend Alex again. Whatever. Not just a person, although it can be a person, it can be a process or a tool. A single point of failure or a single point of slowness, a constraint, if you will. And I want to talk about the theory of constraints in a minute. You guys probably all know that one, right? Let's get through this first. All right, single point of failure could be the system. A classic example is you are running your test automation serially, one test after a time, because it can't run in parallel, because your testers don't know how to write thread-safe code or whatever. Waste, idleness, or backlogs. Those are other causes or signals of where about bottleneck is. Once you find out where the bottleneck is, or maybe you can't, getting my Agile jujitsu going on here, a Gemba or a Gemba walk. So walk around. The thing is, people at conferences are always talking about highfalutin things or whatever, or managers are always, if we only implement this, whatever. Now, who's a line worker? Who's an implementer? You're writing code, you're deploying it, you're writing tests. All right. So the few of you guys know what's wrong. The guys in the trenches know what's wrong, and they probably know the fix for it, right? You were saying, what's your name in the wheelchair?
Oh, Rory.
Rory. You're saying, I know what the problem is, the mainframe or whatever. I can't fix it though, right? The guys in the trenches probably know the problem. Get out there and ask them, for those of you who are in leadership roles, and you'll find out what the real problem is. Now, a leader probably has a perspective that the person who understands the problem has, and that is there may be resource constraints. Yeah, we know the mainframe is the issue. We're not going to replace the mainframe right now. Do you know how much that would take to do? Or, yeah, we know we're shipping with a lot of bugs, but if we don't do it, then Google's gonna eat our lunch, and it doesn't matter if our product releases next year. We've got to get something out right now. Or if you're Google, it doesn't matter if people are gonna make fun of you for making black Nazis. We need to compete with OpenAI. Anyway, ask people on the ground, but take that higher level perspective of what the business priorities and goals are. And if you still don't know, it's time to brainstorm. You've got to ask, well, why didn't you get the testing done? Well, because the environment wasn't ready. Why wasn't the environment ready? Because the SREs were playing video games. Why were the SREs playing video games? Because the testers didn't get the test scripts done, right? You get a circular logic, but if you get past 5 reasons, yeah, you probably either got circular logic or you don't know the answer. And if that's the case, you're screwed. So let's talk about flow. I'm gonna jump right. Now, we all know what getting in the zone is, right? When everything's flowing, it's working, there's no bottlenecks, no constraints, no interruptions, and you understand everything and it just works, right? Stopping people from getting in the zone, stopping processes from being in that zone of continuous delivery is the pain, right? And now we'll back up. there are some things that interrupt the flow. Turbulence and friction, right? Those are the two main ones that I want to talk about. So turbulence, here's things that cause turbulence. Shout out if you have some others. Changing requirements. That should be a drinking game, requirements, or bureaucracy or whatever. Anyway, take a drink if you care. Unanticipated work, interruptions, discovered complexity. Unpredictable changes, I guess those kind of go together. Scheduling conflicts, tight deadlines, and interruptions. So these three kind of go together, and often because of this, which I don't know. But anyway, so turbulence, change, unexpected changes in general, interrupt the flow. Friction. Now these are things like miscommunication, complex or inefficient processes, bureaucracy, internal app developers and their crazy UI decision making. You work with what you got, especially on tight deadlines, and there might actually be a reason for clicking that accept. Are you really sure? In the Phoenix Project book, has anyone read that? I remember an example that stuck out in that book, which was someone developed the internal tool for change management, and the complaint was, well, you know, there's like 1,000 drop downs, and then you have to manually enter in a bunch of information because it doesn't cover everything. And there was a good answer from the manager in charge of that change management tool, which was, we need valid input, right? So the drop-down box with 1,000 options, none of which applied to you. The idea there, the intent was, we want people to tell us the right information. The way we did it might not work, but that was a good example of a competing goal, right? In order to make sure that the changes are understood, we need to know what scope they are. But that may be making it more difficult for the people who need to make the changes. Bureaucracy, take a drink, and interruptions again can cause friction. Back pressure. Now back pressure is what causes that glug, 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 right? Empty. The idea is work builds up. That's that Kanban board where there's a lot of back pressure for QA. That can also cause stress, which can create turbulence and friction. And so you need to eliminate that. We'll talk about how you eliminate that. Short answer is keep your flow steady. Understand where you measure the time and the capacity of those resources. If testing is too slow and it's slowing everyone else down, maybe instead of hiring new developers, you should hire a new tester. Or revisit what's slowing testing down. Allocate some machines for running test automation or whatever. All right, things that can help you get in the zone, right? Having single task workflow. Interruptions, context switching, stuff like that can definitely interrupt the flow. Remove waiting or, no waiting helps you be in the zone, right? If you wait and you're a DevOps engineer, you're gonna start playing NetHack or something. Anyone know NetHack? It's a text-based game. It's, all right, tough crowd. It's like an old Unix command line video game where you're an @ symbol and you run around killing V for vampire and D for dragon. All right, never mind. But when you're in the zone, creativity helps you to be in the zone. So single task, I'm an assembly line worker. I push the button every day. That's going to stifle creativity. It's going to keep you out of the zone. So there needs to be a balance between keeping things simple and regular and giving people variety, the ability to explore and find solutions and learn and grow. All right, here's where I try and get agile process, and since you guys all know more about this than me, Kanban, Kaizen, right? Talking about Kanban, measure your work in progress. That's what the Kanban board's for. Not for managing people and complaining that this blue ticket isn't done. Yeah, that was what that's it. The other part of Kanban is pull, not push. You accept a task when you're ready to do it. You don't let right? That's clearly how you stop buildups. That's what stop signs, or I mean stoplights do. Well, no, they don't do the pull, but they try to avoid the back push. But maybe a better example would be the push to walk across the street, but you only need to do it when you need to do it. Otherwise, let traffic continue. But if you take on work in progress only when you have capacity, then you can avoid things like flux or context switching, things like that. Or the stress of back pressure from work building up. And get those scrum masters off your back. So waiting and waste, in the Japanese Zen Fu Toyota process, that's called Muda, which is waste. When you're when you have a backup of tasks partially complete and the world changes under you, say you're Google and you're focusing on, I don't know, Google Teams or Google Plus or something, and then along comes OpenAI, and you're like, wait a minute, search is no longer relevant because of large language models. All that, hypothetically, right? The idea is that the work that's in progress that now needs to change or be redone becomes waste. And then Kaizen literally means like more better or get good. Continuous improvement is probably a better translation. But the idea is to do continuous incremental improvements. Don't try and eat the elephant, or how do you eat the elephant? One bite at a time. Go for little wins. Any Dave Ramsey fans or enemies here? Right. So Dave Ramsey has a concept for helping you get out of debt. He says, list all your bills, identify your bottlenecks or your debts. Pick the smallest one and pay it off. Now, in reality, that's not the most efficient way, right? You should pay the highest interest bill. Whether it gets paid off or not, it's going to reduce better. But picking the smallest one, number one, gives you a sense of accomplishment, right? It gets the ball rolling, gives you a quick win, it gives you a morale boost. Number two, the money that was spent, or in case the resources that are needed to solve that problem, can now be dedicated to other things, especially from an operational context. Say you have a DevOps guy I've got to back up the logs every day because it fills the disk or something. I'm making this up, but this sounds plausible. Anyone do that sort of? I've got to do that every day. Well, what if we spend a couple days and get that, take something off of someone's, take the other responsibilities off of someone's table so that they can fix that one problem, and now they've got an automated backup. It's rsync on cron, or it's a commercial product, I don't know. But all of a sudden, that's something that might have taken them 5 minutes every day. But if you have a meeting and you have an hour free and you have another meeting, what do you do in between? You're surfing the net, or you're playing that video game or whatever, right? You've got those little interruptions. So if you can free up time, you need a big block of time to get into the zone. Those little interruptions that you do in those gaps of time reduce your ability to get into the zone. So that's another reason to do those continuous small improvements. And then I mentioned this a couple times, evenly spread the workload so that you don't build up back pressure, so that, right? If development is your bottleneck, hire more developers or train your developers, or fix the problem. If testing's your bottleneck, figure out what the issue with testing, and I listed a whole bunch, and take the time, take the money, right? You've got that iron triangle. Something's got to give, speed, quality, or cost, or whatever. Fix the problems, or evenly spread your workload to avoid the back pressure, which can cause turbulence and blah, 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 right? And then empower individuals, judoka, right? In order for the pull process to work, You have to say, I trust you to do the work and to know what to do. Now, your job as a manager is to say what the priority is. The job of the worker is to say, I can now take this next high priority goal. So you've got to empower the individuals not just to take their work, but to stand up and call a stop, right? And in the factory, it would be pulling the chain, right? There's a quality issue, or there's an environment issue or something. Let people speak up, give them the chance to experiment, to make to identify problems, and to say, we need to stop production, fix the problem, whether it's a quality problem or a bottleneck or a roadblock, and take them serious. That's just I guess my thing is the people know the problems. Listening to them and dealing with those problems is I guess the magic wand, right? Okay, but bottlenecks can be a good thing, right? A gate into a castle, drawbridge, whatever. Sometimes you want to restrict flow. You want to not let everyone push deploy to production. There's a good reason for that sometimes. A turnstile. Sometimes you want to measure the flow of traffic, and that might mean making people line up and do that. Or you've got a ticketing system like in the subway or something. Dams are another example of a bottleneck. I guess this is a roadblock, but technically there's a little bit of flow going through. A dam creates a resource pool in the background, and also, you can harness that energy.
That's more like my Jira board right there.
This is Hungry Horse Dam in Montana. Until China got into the business a few years ago, it was the 4th highest dam in the world. I think it's probably still 4th highest in the U.S. Roundabouts and on-ramps and stuff like that, right? Sometimes giving people a little extra runway helps to avoid bottlenecks. Other times it just delays the bottleneck till later on down, right? And you've probably seen both instances where a ramp or a bottleneck or a cloverleaf benefits, and other times it's a waste. And oftentimes it's in the neighborhoods where they put them in to make you feel like you're in England when you're not. Right? It would have been perfectly fine to have a stop sign, and they got a roundabout. And us poor Americans get confused. But anyway, a roundabout could be a good thing. And lastly, a rocket or a nozzle. I really wanted to get a bottle of Coke and a Mento to show it, right? So, combined with the idea of a dam with a reservoir behind it, I don't have a good analogy for this off the top of my head, but a nozzle constricts the flow, and you need the back pressure to do it. So this is, I guess, technically, for those of you who are managers, yelling at your staff to work harder will make them work faster. That's the theory behind the rocket. That's a bad example. Forget I said that. Okay, that's it. Thanks. I'm Aaron, and I'm a test consultant or test strategy consultant. And so, thanks, guys. Any questions or comments? Nope. How are we doing on time? Oh, I'm over time, and you guys stuck around. Thanks. There's more drinks if you want them.